Hello and welcome to Cannon County High School Algebra 2. We are going to move on from trigonometry and we're going to delve into probability today. And today is just going to be an introduction to probability, and it's mostly, I'm hoping, going to be a review of things that you've learned in previous classes, but we need to get our feet wet and make sure we understand some of the basics before we go on to some things that I'm sure you haven't talked about in other classes. So we're going to start doing that today. So Mr. Lyon, as always, you're going to have to watch from over there. And we are going to start with just some basic vocabulary with probability. And the first bit of vocabulary you need to know is, what is a sample space? Because you'll be hearing me talk about the sample space of a given set of probabilities, and that's just the set of possible outcomes. So for instance, if you're flipping a coin, the sample space is heads or tails. Okay? That's as easy as I can put it, I guess. It's just the set of everything that could possibly happen. And an event is a set of outcomes that's within that sample space. So again, talking about flipping a coin, heads would be an event within the sample space of what can happen when you flip a coin. All right, so sample space and event are two vocabulary words you're going to hear over and over again. And this is also very important. It says for each outcome X, the probability of X, this right here is the notation we're going to use. We're going to say X is the event, or the outcome rather. P just stands for probability, so the probability of X has to be between 0 and 1. 0 means it absolutely cannot happen, and 1 means it absolutely must happen. So for instance, if I say, what's the probability of flipping a coin and getting something other than heads or tails? Well, that's 0, and getting heads or tails would be 1. So if it can't happen, it's 0. If it has to happen, it's 1. That's what you need to know for that. And just for an introduction today, I think what I'm going to use, because almost everybody is familiar with them, playing cards. We're just going to talk today about some basic probabilities with playing cards, because most of you are probably familiar and have played some card games with your family in the past, and so most people are familiar with cards. If you're not familiar with cards, that's okay, because I'm going to familiarize you with those, and then we're going to just do some basic probabilities with cards, just to kind of get our feet wet again and kind of start understanding again what some basic probabilities are, so we can kind of use this as a jumping off point. Okay, so cards. You need to know a little vocabulary about cards. Suits. There are 4 suits. There are spades. There are, that's not spades, that's clubs. Clubs. I'm trying to see if I can find some others here. There we go. Spades, hearts, and diamonds. So you've got 4 different suits. There are 13 clubs and 13 spades and 13 hearts and 13 diamonds, which add up to 52 cards total. Okay, and I know I'm telling you something you already know, but there might be a few of you who haven't played very many card games, and so you might need to write this down just to help you with the probabilities. Okay, each suit has an ace, a 2, a 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. So those are the 13 cards within each suit. So again, I know you know this, but just in case you don't, face cards are cards like the king or a jack or a queen, because they have a face on them. So that is considered a face card. So if I ask you about face cards, that's what I'm talking about. Okay? So let's take a look at some of these, see what we get. Let's try some probabilities. So as I'm going through these, you, because you have probably done some of these probabilities before, just tell me what the probability is. If I were to draw, and all these are just going to be, if I shuffle the deck and I would draw a card at random, so I just take this deck and I shuffle it up and I draw a card at random, what's the probability of a certain outcome? So for instance, if I were to say, if I shuffle up the deck and I say, what is the probability of getting a diamond? You would say what? Well, there's one favorable outcome out of a possible 4 outcomes, right? Because there are 4 suits. So there's 1 out of 4. And that's the right answer. So you have a 1 out of 4 probability. Now remember, all the probabilities have to be between 0 and 1, and 1/4 is certainly between 0 and 1. Now you might have done that a different way and said, well, that's not the way I did it. I did it by saying there's 13 diamonds out of a possible 52 cards, so I got an answer of 13 out of 52, which is also correct. But just like in any math class, you want to write your answers in simplest form, and 13 over 52 reduces to 1/4. So either way, you get 1/4. All right, let's try another one. What's the probability of choosing a red card? Again, shuffle up the deck. What's the probability? Aha, we were lucky. What's the probability that you get a red card when you draw that card? Well, half the cards are red and half the cards are black, so that means you've got a 1/2 chance. Okay? Don't say 50. Sometimes people say 50. If you say 50-50, that's, I guess, technically right. Don't say 50 because what you really mean then is a 50% chance. All probabilities have to be between 0 and 1. So in this example, we're going to be just using fractions. So again, you might say, well, there's really 26 red cards out of a possible 52, but again, 26 out of 52 reduces to 1/2. What's the probability of getting a 4 clubs? Well, there's only 1 4 clubs in the entire deck, so that's 1 out of 52. Okay, I know this is really basic, but we're just taking it easy today. We're just gonna, like I said, get our feet wet on how to do these. What's the probability of getting a red or a black card? What's the probability of getting a red card or a black card? Well, all the cards are red or black. That one's red, that one's red, that one's black, that one's red. I don't see any other colors possible. I'm getting a positive outcome every single time. So, what's the probability of getting a red or black? Well, that's 52 cards divided by 52 cards, which is 1. That is the highest probability possible. So, when you draw 1 card from a standard deck, all the cards are going to be red or black. How about this one? What's the probability of getting a pink card? Well, unless your deck of cards is the Barbie, deck of cards, I don't have no idea. Maybe there is some, but on a standard deck of cards, there are no pink cards. So that is a 0 out of 52, which reduces to 0. So there's 2 examples. The highest probability, it has to happen. You're either getting a red or a black, or a 0 probability. It's not going to happen. There are no pink cards in the deck, so you're not going to get a pink card. What's the probability of getting a face card? Okay, well, we just talked about face cards earlier. Face cards are these. They have faces on them. So, how many of those face cards are there in the deck? Well, there are, let's see if I can bring this back up. There's the Jack, Queen, and King. There are 4 jacks, there are 4 kings, and there are 4 queens. So that means that there are 12 face cards total. But you could even simplify it. You could just say, well, think about it in terms of there's 13 kinds of cards. 3 of those cards are face cards. So you get 3 out of 13. If you did it the other way, and you said there are 12 out of 52, well, take a wild guess as to what 12 out of 52 reduces to. Yes, it's 3/13. So your probability of getting a face card is 3/13. How about the probability of getting an odd numbered card? Okay, well, how many odd cards are there? Let's look back up here. Remember that an ace isn't really considered, that's not really a number. I know you can give numerical values to each of these, but an ace is not really a number. So let's see, 2's not odd. 3's odd, 5's odd, 7's odd, and 9's odd. So that's 1, 2, 3, 4. There's 4 out of the possible 13 And so the probability of getting an odd is 4 out of 13. If we would have counted them up individually, it would have been 16 out of 52. But again, that reduces to 4/13. Let's try this one. How about the probability of getting a black 7? Well, how many black 7s are there in the deck? Let's see. Black 7s. Black 7s. Black 7s. Where are they? Must be they must be in here somewhere. What are the black 7s? There's one. Black 7. There's one. There we go. There are only 2 black 7s, so 2 out of a possible 52. What does 2 out of 52 reduce to? 1/26. And so there's a 1 out of 26 chance of getting a black 7. Okay? Let's try just 1 or 2 more. What's the probability of getting a 2? Well, there are 4 2s in the deck out of 52. So what is 4 out of 52? That's 1/13. So the answer is 1/13. All right, last card problem. What's the probability of getting a one-eyed jack? Do you know this? You've probably watched some Western movie where they're playing poker or something like that, and they're talking about one-eyed jacks are wild. Did you know what they were talking about? Here are all the jacks. Look closely at them and tell me which of these jacks have one eye showing and which of these jacks have 2 eyes showing. It looks like the jack of hearts has only 1 eye showing. It looks like the jack of clubs has 2 eyes showing. Jack of spades, 1 eye. Jack of diamonds, 2 eyes. So what's the probability of getting a one-eyed jack? Well, a one-eyed jack, there's only 2 of them. There is the jack of spades and the jack of hearts, so that's 2 out of 52, which again reduces to 1 out of 26. So there's a 1 out of 26 chance of getting a one-eyed jack. And of course, you can do lots of different things having to do with card games and that. But I just wanted to give you a quick overview on some of those. And what I'd like you to do is go to IXL CC.1, and what they're going to do on CC.1, they're not going to talk about cards. I just brought the cards out because it's something I know most of you are familiar with, and it would be a good way to introduce some of these basic ideas. But this is what the IXL is going to ask you. It's going to ask you something like this, and it's relatively easy. You'll get through CC.1 in like less than 5 minutes. But it says, could 0.43 be the probability of an outcome in a sample space? Could it? Well, you know that the probability in a sample space has to be some number between 0 and 1. So is 0.43 between 0 and 1? You would click yes. I'm not going to bring the computer out, but you would just click yes on that. Here's another example of what they might ask you. You'll have to excuse the fact that I had to cross that out, but it says, does, I put could, does the table below show values of a valid probability function? So look at these values. What has to be true about each one of those values for it to be a valid probability function? They each have to be between 0 and 1. Are they? Yes, they are. Now, what else has to be true about a table of values for a probability function? They all have to add up to how much? What has to be true about all the probabilities in a sample space? They all have to add up to 1. Just like the heads and tails, probability of heads is a half, the probability of tails is a half. If you add up a half and half, you get 1. Look at cards. The probability of any individual card is 1 out of 52. But if you add up 1 out of 52 plus 1 out of 52 plus 1 out of 52 for all 52 cards, you get 52 out of 52, which is 1. So what they're really asking you here is, do these numbers add up to 1? 0.3, 0.4, 0.1, 0.2. Let's see, that would be 0.3 plus 0.4 is 0.7, 0.8. Yes, this adds up to 1. So you'd click the yes and keep going. So they're just going to ask you some really basic things that have to do with probabilities and sample space and events. Okay? So again, this was just an introduction. We'll get into some more meat and potatoes of this type of thing next week. So I hope all of you have a wonderful weekend, and I will talk to you next week. Bye.